Okay, Phoebe, I'm going to do page 151, number 80. I'll try to do a few more of these, and I'll look over some of your even problems, but maybe you could let me know which even ones you don't get, so that I don't waste time doing some that you already know how to do. This is number 80. You're supposed to consider the rectangle with length x, perimeter is p, and that's equal to 36. You're supposed to write the area as a function of x and determine the domain of the function, graph the area function, find the length and width of the rectangle of the maximum area. This one's a little bit challenging. So we know the perimeter is equal to, oops, I gotta get the right color here, hold on a second. Perimeter equals 2 times the length plus 2 times the width. I just let that equal y, because we need two variables. We know the perimeter is 36, so we can put 36 in there for p. And then we can, to make this equation simpler, we can divide everything by 2. This is all divisible by 2, so you get 18 equals x plus y. And then we want this in terms of x, so we're going to solve it for y. So we're going to get 18 minus x equals y. And that is the width. So to find the area, it's the length, which we already have as x, times our width, which is y, which is 18 minus x. And they want us to graph this. So if we multiply this out, I'm going to get negative x squared plus 18x. You can see it's a parabola. They also wanted to know the domain, and you can't have negative numbers. So we know that our x values have to be in between 18, because if it's bigger than 18, it's going to be negative. And if it's 0, it's going to be 0. So it has to be greater than 0, and it has to be less than 18. That's your domain. That's your part B. Part C, you want to graph this function. So you could just plot that in your calculator. Excuse the bad lines there. And we know it's a parabola, it's going to open downward. Now remember, I was starting to tell you about how you can find the vertex using this formula. You can find out the vertex by the x-coordinate of the vertex by remembering the formula that x equals negative b over 2a. So I can tell you the vertex of this parabola is going to be, this is b, negative 18 over 2 times negative 1, so it's going to be negative 2. So the vertex of this parabola is going to be 9. So that means we're going to get down to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be somewhere up here. Actually, if you put it in, I put it in and I got that it equals some big number, 625. So it's going to be way up here, 625. The scale will be totally different. This would be 625. And it's going to be a downward opening parabola. I can't draw very good on this thing. But what they want is the maximum, so you draw your parabola, what they want is the maximum width and length. So we know that our x value, our length, is going to be, I can surely do better than that. Can't concentrate with my dog whining behind me. So here's my rectangle. We know our length, our x value, which we just found up here, our x value, the maximum x value is 9. So their maximum length is 9. We also know that the perimeter has to equal 36. So the only other numbers, this would be 18, so each of these would have to be 9. And so, to answer the question, the maximum area would be 9 times 9, or 81. And it's in meters squared. So our maximum area is 9 times 9. And so you get your maximum x. This always gives you the x-coordinate of the vertex. And then the way I got the 625 is I took this 9 and I put it back in here. Actually, it came out to be 81. That was another problem I was doing. This is 81. I put the 9 back in here. 18 minus 9 is 9. 9 times 9 is 81. So that would be the y-coordinate. But you couldn't have this side being 81 and still have a perimeter that adds up to 36. So hopefully that's helpful. It's a kind of tough problem. It's a multi-step problem, but hopefully that helps.